Okay, guys, we're going to take a look at the sine and cosine ratios today. If you understood the last lesson on the tangent ratio, then you should be in good shape. This lesson falls right from that. The ideas of solving the equations is very similar. Anyway, while you get your calculator out, make sure that you're in degree mode. We talked about that last time. If you're not there, go to second in the mode button and make sure you're not in radian, but degree mode. All right, let's take a look. First of all, the sine ratio. It's defined here, the sine of acute angle of a right triangle. It is the length of the opposite leg to the length of the hypotenuse. So with that being said, it's once again, it's for an acute angle of a right triangle. It is a ratio, and the ratio is equal to the length of the opposite leg to the length of the hypotenuse. So if I take this definition and I put it into an equation, it's going to look like this. The sine of theta, remember theta is just a way that we talk about an angle measure. Sine of theta is equal to the opposite over the hypotenuse. In this particular diagram, if I look at angle A and I ask for the sine of A, well, the opposite is side A over the hypotenuse. Well, here's the right angle, so the hypotenuse is here at C. So it would be sine of A is equal to A over C. Well, the sine of B, well, what's the opposite side to B? Well, that's the side length of B, and over the hypotenuse is C. So the sine of angle B would be B over C. All right. Cosine, very, very similar to this. It talks about the cosine of acute angle of right triangle. It's now the ratio of the length of the adjacent to the length of the hypotenuse. So once again, it's a ratio comparing the length of the adjacent leg to the length of the hypotenuse. All right, well, take a look. Cosine of theta. Well, theta is our acute angle of our right triangle. Taking that definition, put it into equation form with some words, and the cosine of theta is equal to adjacent over hypotenuse. In the diagram, if I looked at angle A, the cosine of angle A is the adjacent leg. Well, the adjacent leg is B over the hypotenuse, which is C. So your answer would be B over C. Or if I wanted the cosine of angle B, the adjacent to B would be side A here over its hypotenuse length of C. So that would be A over C. All right, taking a look in here at our next slide. I'm sure that all of you are familiar with the chief here, probably seen him in many textbooks back in your younger days. The chief is good at helping us to remember the sine, cosine, and tangent ratios. If you don't remember the story, he was a young warrior back in the day. His tribe was under attack, and as he was running through the fields where they were trimming down the trees and clearing land so they could make land to put their crops in, he running hard in battle. Boom! Hits his foot on a tree stump. Oh, can you imagine the pain stubbing your toe running full speed while in battle? Well, while he did this, he had this problem for the rest of his life where his big toe would always swell up. So he would go down to the river and he would have to soak his toe in the river. Hence, he had the name of Chief Sokotoa. All righty. Yes, here we go. Chief Sokotoa. Actually, Chief Sokotoa, just a made-up story, obviously, but it helps us remember our sine, cosine, and tangent ratios. The sine, S-O-H, so, is the sine is equal to O-H, O over H, which is the opposite over hypotenuse. Ka, C-A-H, that stands for the cosine is equal to the adjacent over hypotenuse. And then the TOA is what we learned last class with the tangent ratio, which the tangent we know is opposite over adjacent. So ka, hoa. Old teacher I had back in school taught me that he would use that Oscar had a hold on Arthur. Okay, so that was another memory device that was used, and all those are memory devices to help you to remember your ratios for your sine, cosine, and tangent ratios. All right, on to the next. How do we use this? We're going to use this very much like we did the tangent ratio. We're going to use it to find unknown side lengths and also angle measures. On this slide, we're going to find some side lengths. So to start with, let's take a look. It wants us to find the length of C. So here's my unknown at C, and they give me this reference angle here at 25. Well, now you've got some decisions to make. What am I going to use? Well, I've got this reference angle of 25. I want C, and the other value I have is 5. Numbers are good for equations. I don't want another variable A in my equation. So when I look at that, 5 compared to 25 is the adjacent leg. C is the hypotenuse. And adjacent and hypotenuse, I'm going to use the C, or the cosine, to set this up. And it's the cosine of my acute angle. The acute angle they give me here is 25 degrees. And that's equal to the adjacent of 5 over the hypotenuse of C. Remember, the cosine of 25, that's just some decimal number in the calculator. And I can divide any number by 1. So I'm going to do that to set up a proportion. And when I cross multiply or take the product of the means and extremes, I've got C times the cosine of 25. And that's equal to the product of the means, which is 5 times 1. Well, that's just 5. All right, to solve this, I've got C times the cosine of 25. Remember, cosine of 25 is just a number. So I'm going to divide the cosine of 25. That would cancel out here, leaving me with C, which is what I'm solving for. And I divide this side by my cosine of 25. And then it's down to using the calculator to figure this out. So I plug this in, 5 divide cosine of 25, and voila. I get 5.52, I guess we'll go round it off. So 5.52. Now remember, as you do these, I want the 3 steps. I want your equation, what you're plugging in a calculator, and then your answer at the end. All right, let's take a look at our next one. In the next example here, the reference angle they're giving me here is 65 degrees. They're asking me to find the measure of B, or the length of B. Well, B is the opposite side. The other number I have here is 10, which is my hypotenuse. So I've got opposite and hypotenuse, and oh my gosh, oh yeah. It's the sine, because it's OH, opposite and hypotenuse. So we're going to take the sine of my acute angle, which they give me is 65 degrees in my triangle. And that's equal to the opposite side of B over the hypotenuse of 10. Well, this sine of 65, that's just a number. I can divide by 1 and set this up as a proportion. The product of the means is B. 1 times B is B. The product of the extremes is 10 times the sine of 65. So down to the calculator activity, I'm going to take 10 times the sine of 65 over here. Clear what we had before, 10. And then the sine of 65, and we hit enter. All right, so in the end, B, or the length of this side, ends up being 9.06 if we round that off to 2 decimals. And there we go. Much like the other day, guys, there's only 2 scenarios of what can happen. The unknown could be in the denominator, in which case this is how you would solve, or the unknown length could be in the numerator, in which case this is how you'd solve. Here's my equation. There's what goes in the calculator, and my answer, all 3 steps each time. All right. All right, let's take a look at the next one here. Once again, now it's asking me to find the measure of angle A. So this is my unknown value right here at A. And they're giving me this side length here at 5 and this length here at 12. I want numbers. I don't want to use the B because I don't want an unknown angle and an unknown side. I wouldn't be able to solve. So I look at angle A. And I say, oh, 5 is the opposite, and 12, yeah, that's the hypotenuse. Opposite, hypotenuse. Oh my gosh. Oh, H, yes, it's the sine again. So I take the sine of my acute angle, which I don't know is A, is equal to the opposite of 5 over the hypotenuse of 12. There's my equation. Now, to solve, remember to find an angle measure. To get the angle by itself, I have to move the sine to the other side. And the opposite of sine, last time we talked about the tangent inverse. Well, the opposite of the sine is the sine inverse, which you're going to see it written as sine to the -1. Ooh, -1, there we go. And of 5/12. So that's what I plug in the calculator. Remember to get the sine inverse or any inverse, use the second function key. The second function, sine inverse of 5. I can make this into a fraction, 5/12. Get out of my fraction, close my parentheses, and the angle measure we're looking at is approximately, I'm just going to go to the 10th. It's going to be approximately 24.6 degrees. All right. Next problem, taking a look. They're asking me here this time to find the measure of angle B. The two sides they're giving me are the 6 and the 10. Well, the 6 is the adjacent leg. 10 is the hypotenuse. Yes. Adjacent and hypotenuse. Cosine. So I look at the cosine of my angle I'm looking for, which is B. The cosine of the acute angle is equal to the adjacent of 6 over the hypotenuse of 10. Could I reduce that to 3/5? Most certainly I could. Not a huge deal here, though. I'm going to say that B then, to solve, remember to get rid of the cosine, I've got to move it to the other side, and you do the cosine inverse. So the cosine inverse of 6 over 10. And I plug that into the calculator. We'll clear that off. Here we go. Second, cosine 6. And maybe I don't do the fraction. Maybe I do division this time. So 6 divided by 10, close parentheses. So the cosine inverse of 6/10, and enter. My angle measure is approximately 53.1 degrees. Equation, what goes into the calculator, in my answer at the end. Much like we talked about the other day, guys, if you're finding an angle measure, whether you're using sine, cosine, or tangent, as you solve it, you will be using your sine inverse, and you will use, or the sine, cosine, or tangent inverse, and you will use the inverse on your calculator. If you're finding a side length, I guarantee you every time to find a side length, you will be either using sine, cosine, or tangent, not the inverse. All right, that's it for the day. Here's the optical illusion. Hope that you guys are experiencing success here with this. If you have questions, get into the chat. We'd love to see you. And guys, have a great day.